Mathematics Class 8th, Chapter 3rd, Understanding Quadrilaterals, Exercise 3.1. Here we are on question number 3rd. What is the sum of the measures of the angles of a convex quadrilateral? Will this property hold if the quadrilateral is not convex? Make a non-convex quadrilateral and try. This question asks us to find sum of measures of the angles of a convex quadrilateral. And we know very well from our question number 1st and 2nd that a convex quadrilateral is a quadrilateral whose internal angle is less than 180 degrees. So let's try to construct a convex quadrilateral. Here we constructed a quadrilateral named as ABCD. A quadrilateral is a polygon, that is, it is a closed curve entirely made up of line segments, where starting point is also the end point. Here we started from A, we constructed it like this, moving to B, then to C, then to D, and finally we terminated at the starting point, that is A. Since it is closed, therefore it is termed as a convex quadrilateral and it is a polygon. This was just a revision of what we have learned in question number 1st and 2nd. For a deep understanding, you should watch question number 1st and 2nd. Now, in our case, our angle A is 66.7 degrees, angle B is 90 degrees, angle C is 101 degrees, and angle D is 102.3 degrees. And the question asks to find the sum of measures of angles. So we wrote 66.7, we wrote 90 degrees, we wrote 101, and at last we wrote 102.3 degrees. We are going to add it up. So 7 plus 3 is 10, carry forward. 6 plus 1 is 7, 8, 8 plus 2 is 10. Again carry forward. 9 plus 1 carry makes 10, 10 plus 6 is 16. So 6 came, carry again. 1 plus 1 is 2, and 2 plus 1, that was carry, gives us 3. So we found that sum of measures of the angles of a convex quadrilateral is equal to 360 degrees. And it holds true. If you make any possible convex quadrilateral that you can imagine and draw, the sum of all 4 angles inside the boundary of a convex quadrilateral will always give addition as equal to 360 degrees. Well, this was a practical approach in order to find sum of measures of angles of a convex quadrilateral. That was the method number 1. We would also like to tell you method number 2, with how conceptually you can find sum of measures of angles of a convex quadrilateral. Let's consider our vertex A. We are going to construct a diagonal, and you know very well from question number 1st and 2nd that a diagonal is just a line segment connecting two non-consecutive vertices. So if we consider A, then vertex D and vertex B are consecutive to it and we cannot draw. Therefore, we are only left with vertex C, and which is non-consecutive vertex to vertex A. Therefore, we can connect A and C with the shortest distance possible, which will be called as diagonal, and we can construct it like this. We start from A and we construct the shortest distance to C like this. Therefore, this is called as the diagonal. Well, construction of this diagonal gave us an interesting result. Here we can visualize two triangles formed, namely triangle ADC and triangle ABC. So let's name it. This is our triangle number 1st and this is our triangle number 2. And you know very well angle sum property of a triangle. The measure of angle ADC will be 180 degrees for triangle 1st. Similarly, triangle 2 angle sum property will be equal to 180 degrees. And when you add 180 plus 180, it gives you finally 360 degrees. Hence we can conclude that the sum of measures of the angles of a convex quadrilateral will always be equal to 360 degrees. With this, we have completed A part of our question. Now it says, will this property, the property it is referring is this only, that is, sum of measures of angles of convex quadrilateral equals to 360 degrees. Will it hold if the quadrilateral is not convex? It simply means we have to construct a concave quadrilateral. And you know very well again from our question number 1st and 2nd that a concave quadrilateral is a polygon whose at least one of the angle inside the boundary of that quadrilateral is greater than 180 degrees. So we try to construct a concave quadrilateral. We named it as quadrilateral P, Q, R and S. Here if you observe angle Q, that is this angle is greater than 180 degrees. In our case it is 204.3 degrees. Well, angles can be in decimals as well. It is not always a whole number. Now let's try to add all these angles, that is angle P, Q, R and S. So we wrote the same. Now let's add them up. 4 plus 3 7, 7 plus 2 is 9, 9 plus 1 is 10, carry. 8 plus 1 is 9, 9 plus 4 is 13, 13 2, 15, 15 5, 20. 2 is carried, 4 plus 2 is 6, 6 plus 10 gives us 16, 1 carry, 2 plus 1 is 3. To our surprise, it again came as equal to 360 degrees. With this practical finding, we can conclude that the sum of measures of a concave quadrilateral is also equal to 360 degrees. But to confirm our findings, let's try our method number 2. And this time, let's take our vertex Q. So we cannot construct a diagonal from Q to vertex P and R very well, because these are consecutive vertices and we can only draw our diagonal from two non-consecutive vertices. So we can only draw our quadrilateral as Q to S. Therefore, let's draw the same. We start from Q like this and move all the way to vertex S. This again gives us two triangles within. Triangle PQS, let's name it as 1, that is first triangle, and second triangle as triangle QR and S. Let's name it second. Using the same concept as we used in this part, the sum measure property of a triangle PQS will give us 180 degrees. Likewise, angle sum property of triangle QR and S will give us 180 degrees. Indeed, 180 plus 180 will again give you 360 degrees. Therefore, we can say yes, that this property will hold true for even a quadrilateral which is not convex. That simply means it would be concave quadrilateral. Therefore, with this result, we come to our final conclusion that take any quadrilateral, the sum of measures of all its internal 4 angles will always be equal to 360 degrees. This is an important truth to be learned. With this, we have solved a question number 3 of chapter 3, Understanding Quadrilaterals, Mathematics class 8th.